Okay. So today we are going to talk about the rest of the lecture for asynchronous callbacks and in general asynchronous functions in JavaScript. Okay. You find as usual the updated schedule on the course website. Yes. So the schedule is here. Tomorrow there's a lab, right? So now, today we are here. I will put as soon as possible the slides for the rest of the week. Tomorrow you already have the text for the lab, for tomorrow, sorry. And it's about what we are going to discuss, well, basically last week and also a little bit today. Okay? So experimenting a little bit with the database. Okay. And so today we will continue discussing the asynchronous functions. And you might remember that we left on Thursday with this question. So we have an asynchronous function that is this one, the arrow function passed to the DB_all. That is called when the operation on the database has been finished. Okay, so the query has been executed. And of course we can do operations here, but then how can we say, okay, it's finished, so we want to execute code that is not inside this asynchronous callback, okay? And writing some code like this is wrong, because this code gets executed before the callback, the asynchronous callback is called, okay? So we didn't have any solution for this problem. And indeed, there is no solution unless we introduce some other structures and so on that we are going to do today. Okay? So in short, let's say we have to do a lot of operations on the database, for instance. Think about this example in which we are basically just inserting a single value into a column called number in a table, and then we want to know how many rows are present there, okay? And we want to cycle and do it many times, just as a simple example, okay? How can we ensure that things happen in the order that we would like them to happen? And actually, indeed, they don't happen in the order that we want. That we would expect from the logic of our program, because simply they are asynchronous operations, and so once they are finished, they call our callback, and but the order in which they are enqueued in the callback queue is not decided a priori, okay? We don't know before executing the program. Each time we execute the program, the result can be different. Okay? Just have a look at this file, the queries MJS, which is exactly what is shown here on this slide. Okay? By the way, I recreated the folder for every week. I create a new folder. So week 03, I did it this morning. The DB stuff is the old stuff. Okay? So we'll start here in DB. And there are the examples, basically, that we're going to show in the slide, so you don't have to type them again. And also, I have them available to run and to show them to you. Okay? So queries MJS, I think, yes. So SQLite, import SQLite, DB_run, DB_all. Okay? So data SQLite is a database. Okay, very simple, just one table, one column called number, okay? And we insert data in this table, and there is just one column. It's just to insert something in a database, very simple query to do this, okay? So let's just run the program, queries MJS. First of all, remember, we need to install the SQLite3 package, okay? npm, since I provided the package lock, you remember that package lock gives you the versions of the packages and everything that is needed to install. the same set of packages exactly as they were designed and used by the developer. So npm CI, that means clean install, okay? That is exactly, by the way, the command that we are going to use at the exam, okay? For installing the packages that you tell us to install through this package.json and package.log.json file. So now we have these node modules, and also this import works, right? It should, at least. Queries MJS. Okay, you see the result. You see, for instance, that the number is not consecutive. Okay, what is the queries MJS doing? Just doing a for loop 100 times, insert and select count. Okay, insert count, insert count. Well, actually not in this order, that's the problem. It's just asking the database to perform these operations. Okay, but this operation will happen asynchronously. So at a certain point you count and you get like 99. And then you count again and still 99 because the last insert has not been executed yet. Okay? And so on. Okay, so that's a problem that we are trying to solve today. Of course, we will be able to solve it. Okay? But you can play with this example just to understand that this is a real problem, okay? Not just a theoretical problem. Things happen asynchronously. So we need to have a way to synchronize operations, okay? And in this example, by the way, it's pretty difficult because we would like to execute an operation after the previous one has finished, but it's in a loop, okay? So of course, we could take the code that we would like to execute after and put it into the callback of the previous operation. But then we have a loop and we would like to do it for the other operation as well. And so it's pretty difficult to solve. There is a possible solution. I don't want to show you this solution because it's not recommended, okay? Basically, it's designing a method to be called when you say it's finished, and it complicates things, and there are easier ways to handle this problem. The actual problem, the actual ways that we will use in this course and in JavaScript in general. Okay. So the solution to this problem is using promises. Okay. Promises are quite general concept, not just specific of JavaScript, but again, since JavaScript is very well suited for asynchronous programming, they have been introduced in JavaScript and they work very well in JavaScript. Okay? So promises solve this problem, the so-called callback hell. Okay? So think about this example without having a loop, even just without a loop, as before. That is probably the more complex case, most complex case. When you want to perform another operation, depending on the fact that the previous asynchronous operation has finished, you need to nest the new operation inside the callback, the asynchronous callback of the previous one. Okay? Look at this example. Readline is a package just to do input-output on the keyboard. Okay? We will test it in a minute. And so you type something, and it goes inside a variable in JavaScript. Okay? And of course, it's asynchronous because you need to wait for the user to type something and press enter, the enter key. Okay? And so you don't know when it's happening. But when it finishes, so the user press enter, the content written through the keyboard goes into the variable. So it's and the callback passed to this function question that is basically in charge of doing the input from the keyboard. This callback is called, and then you can proceed with the next operation. But as you see, it's nested because we need to wait for this callback to be called. Okay? So every callback, every time you need to wait for an asynchronous operation, you would add you add a nesting level. Okay? And when you have a lot of callbacks, of course, the code becomes very complicated, very messy. Okay? Let's just have a look at the example. Okay, so read line. Okay, so node read line. Read line is the code you saw on the slides. Okay, task description, we don't care. A, B, C, yes, no, whatever, 0309. No, it's 2016. We don't really care. And then, in the end, it does console log. Okay, but you have to do it here, nested. You have 4 levels of nesting. Okay, so very complicated, difficult to write, difficult to read, and so on. Okay. Just a note, by the way, this read line, I didn't install the read line because there are some packages that comes with Node. Okay, you can just simply import them, and they are already installed in Node. Okay. Okay. So let's try to solve the problem, and the solution are the promises. Okay. So a promise is a core language feature, so a characteristic of the language, JavaScript in particular in this case, to simplify asynchronous programming that can solve also the callback hell, and it will be the basis also of newer functions that has been introduced in ES8, and we will use them a lot. So 2 keywords, basically, async and await, that helps to write asynchronous code in a much more readable manner. Okay, but under the hood, they use this promises mechanism. So a promise, in short, is an object, a JavaScript object, a predefined JavaScript object, like object, array, function, and so on, date, if you like. And this object represents the eventual completion or failure of an asynchronous operation. Okay? When the result of the operation is not yet known. So in short, you call an asynchronous function. This asynchronous function will do operations, but can immediately, synchronously give you back a reference to a promise object. And this promise object will contain the result of the asynchronous operation. Okay? That's the basic idea. So you don't have to nest things, because if you have this promise object will contain the result. You can attach operations to this promise object that are executed when there is the result of this asynchronous operation. Okay? So basically promises also standardize a way to handle errors, because the result can also be an error. You remember that with asynchronous functions, we had this way of handling errors. We say the first parameter is dedicated to errors, and the second one is dedicated to the result of the operation. Okay? And that was just a convention. In an object specifically designed for this purpose, so this promise, there is the information if there has been an error or not, and also the result of the operation and the error in case. Okay? And it will be nice for us because this promise can be chained together. So if we have more than one asynchronous operation that depends on the result of previous operation, we are able to write a simpler code chaining these promises together. And we are going to see how to use them in a minute. So that's the whole explanation, but this full explanation is also reported here. Okay, so let's have a look at the code here on the right, and what's happening that is described on the left part of the slide. So at a certain point, we have an asynchronous operation to be executed, and in this very simple example, okay, is in short this waiting for a certain amount of time. okay, set timeout for 1 second. Okay, the simplest asynchronous operation we can write in JavaScript. Okay, could be a database query and so on. Later on, it will be. Okay, and so we design a function that, in short, instead of waiting for the result and so writing what we want to do after the 1 second is finished here at the place where we pass a callback to be executed after the asynchronous operation has been finished, we design the function in a way that we return a promise immediately, okay? This new promise, and we attach it to the result of the asynchronous operation, and now we will see how. And then afterwards, so after this statement, this instruction, const my promise, etc., semicolon, we can simply use this promise immediately before the timeout expires, so before the asynchronous operations happen. And this promise is used to attach some other code when the promise will have the result of the operation, okay, through this method that is made available by the promise, okay. So in short, this promise object P, this my promise, okay, is created, step number 1, by this new promise, and promise is just an object available in JavaScript, okay. And the promise object takes in the constructor a function to which two functions are passed. Here we are interested just in the first, and then later on we will see the whole signature of the function. So in short, this function is the function to be called to resolve the promise, so to give the promise the result of the asynchronous operation. Okay, and so indeed it is the function here, resolve, that is called when the asynchronous operation finishes. And in this case, the asynchronous operation is just wait 1 second. Okay. This function will be called with a parameter that is just a string, just as an example. Okay, this R, which is the result, okay, of the asynchronous operation. The set timeout after 1 second calls this resolve callback, passing as parameter all the rest that is passed here. Okay, in this case just a string. Okay, the promise will take the result of the operation inside the object itself, and then indeed it will call the callback that has been attached in the second step, so just after the promise has been created, when it has the result of the asynchronous operation. Okay, and here the code is very simple. Take the value of the promise, the result of the synchronous operation, and just print it, console log val. Okay. So if we look at the description, the promise object P is created in the beginning, starts in this pending state. We will see the states in a minute, okay, but that's the initial state, and is returned immediately by this asynchronous function f, okay. And then you process the code as usual, so you do step 2, my promise then. So you attach, again, a callback to the fact that when the promise is resolved, so it gets the result of the asynchronous operation, this callback will be executed, okay? And then number 3, at a certain time, the asynchronous operation finishes, okay? This is the time, it could be the database query and so on. And so the resolve function of this function passed to promise is called, okay, with the result of the asynchronous operation, R. Okay? Good. And the promise that has a final value, the result value of the asynchronous operation, tells JavaScript that now the callback attached to the promise, so this val console log val, is ready to be executed. So it will be put in the callback queue. Okay? Actually, there are two queues. We discover it now in JavaScript. Okay? There is the macro task queue, that is what we called last time. You remember the callback queue. Indeed, it's macro task queue. And actually, there is another one that we discovered only now because it's just specific for promises. That is the place where the callbacks attached to promises are put. Okay, the micro task queue. That is very similar to the macro task queue it was. But it has higher priority. So before executing anything in the callback queue, in the macro task queue, everything from the micro task queue needs to be executed and finished, so that the promise system works well. Okay? Otherwise, the promise system wouldn't help us. Okay? Because it would delay too much the execution of the callbacks attached to the result of the asynchronous operations. And so, step 5, this console log val is executed on the core stack as any other function in JavaScript. Okay? And the promise calls this callback, passing as a parameter, as a first parameter, the result value of the asynchronous operation, this R. That in our case is ret val. And so this will print console log. Okay, it will do console log ret val. Okay? That's a basic structure. Okay, maybe you need to think a little bit more about this. I know it might not be so immediate. Okay, but this is the details of all the steps that are happening when we define a promise. At a certain time, the promise is, we say, solved. So it gets a value that is the result of the asynchronous operation. So let's go into more details how promise work and what happens in case there are errors and so on. So promise have 3 states. A new promise just created always starts with the state that you see here in pending state, and it has no value because the asynchronous operation has not yet been performed. Okay? And then the asynchronous operation is performed, and the result is everything is okay, and there is some results, like when you access the database, the rows from the database, and so on. So the state becomes fulfilled, and we have a value. Okay, there can be any JavaScript value, remember. Strings, numbers, and so on, but also arrays, objects, etc. Okay, any JavaScript value. Just one, but as usual, any JavaScript value. Or, in case there is a problem, for some reasons, there are errors, issues in executing the asynchronous operation, the promise goes into this rejected state instead of the fulfilled state. And this rejected state has the possibility to have a value as well. Okay? So in short, you can use this value to communicate the kind of error that happened. Okay? Can be a string, can be an object, again, can be anything that is valid in JavaScript. This is these 2 states are called settled. I mean, it's the promise in one of these 2 states is called a settled promise. Okay? So it starts in pending, and then at a certain point it's settled. Okay? And it cannot go back. It just starts from pending, and either it's successful, so it's fulfilled, or it has problems, so it's rejected. Okay? Very simple. Okay. Now, how do we actually create a promise? Well, we already saw the example. It's possible to create a new promise with a new promise statement. So promise is a constructor function made available by JavaScript. This constructor function takes what is called an executor function. That is what we saw before, okay? We just didn't use the reject part, okay? So this executor function is a function that takes two parameters, and these two parameters that are passed to the executor function are again functions. JavaScript is always like this. Functions pass around in any place, okay? So we call a function that takes a function that takes two parameters as a function. They are two parameters that actually are functions, okay? And those are functions that needs to be called inside the code of the executor function that does the asynchronous operation. When the asynchronous operation either finishes with success, so you call the resolve, and you pass the value that you want to pass as a result of the asynchronous operation, the successful asynchronous operation, or you call reject with some error information. Okay, a string can be an object, can be anything. Okay, typically, let's say in the database, syntax error in SQL query, whatever you. Database access error, I don't know. You cannot access the information for some reason. Okay, good. So that's the basic structure, the simplest structure to define and actually use a promise from the point of view of executing the asynchronous operation. Okay, and then there's the usage in terms of what happens, what we would like to do when the promise is settled. So when it is either fulfilled or rejected. So we call it resolved or rejected. Okay, and just in a minute we will see it. It's very easy to make functions that return a promise. You just return a promise. Okay. This is very common, and it will be present a lot in our examples during lectures, during labs, and so on. Function, the first thing you do, return new promise, and then the rest of the code is inside the promise. I mean the executor function. Okay, and there you can put the code that you want. Okay, like in this example, for instance, resolve reject if duration less than 0, reject, okay, time travel not yet implemented, because this is like the duration of the delay. Otherwise, set a mount resolve after a certain amount of duration in milliseconds. Okay? Very simple example. Again, you can put the database access code and so on. How to use the promise? So how to attach operations when the promise is settled. We already saw it, okay? There's the then method, and there is also a catch method, and there will be a finally method, okay? So you just have a reference to the promise, but that's easy, right? You just return the reference to the promise. Like here, the function, you execute the function immediately returns the reference to the promise without executing the asynchronous operation. This is synchronous code. You execute the function, it has a return statement. And as we did before, here, promise, new promise. And so the promise contains the reference to the promise object. And then you can immediately use it. And indeed, it's what you typically do. You call the then method on this promise object, and all promise objects have the then method, and also the catch, but we're interested in the then here. And then you pass a callback to be executed once the promise is fulfilled. Okay? Of course, you might want to attach some other code when the promise is rejected, so when you encountered an error. Okay? And the way to do it is using the catch method. Okay? These callbacks are executed asynchronously. So they are queued in the microtask queue, as we said before. That queue, like the callback queue, but with higher priority, when the promise is either fulfilled or rejected. Okay? Remember that these callbacks can take actually as the only parameter the value of the fulfilled or rejected promise. So when the promise is solved, is settled, the code of the promise object will pass the value of the fulfilled or rejected promise to these functions, on fulfilled and on rejected. And that is the way that you can use to get the result of an asynchronous operation and take it out from the function that actually executes the asynchronous operation. That's the problem that we had before, right? Okay. So, in short, it's quite easy to write now the code for the promise. Promise.then, and you write a callback. It takes a parameter that is the result, and then you do whatever you want with the result. And catch, you take the parameter that is the error, so the value that represents the error happened during the asynchronous operation, and you do whatever you want. So in short, on one side you create the promise, and you decide at a certain point to call resolve and reject with two values, and these values will be recovered in the callbacks attached to the promise through the then and catch methods. Okay? That's the basic structure of the promises. Okay? There is also a finally method. Okay? Because this structure with the promises is very similar to the exception mechanism, so the try, catch, finally mechanism. So there is also a finally method on the promises that has a callback that is executed in any case after the promise is settled, regardless that it has been fulfilled or rejected. And there you might want to put some code that has to be executed in any case when the asynchronous operation has finished. Like you want to log something, and you want to log the result in any case, success or error. Okay? This is optional. I don't want to stop on focus on this because it's already complex enough. Okay? But you can have a look at the manual in case. Catch and finally can be omitted if not needed. Of course, you can omit the then as well, but then the promise becomes useless, right? You don't do anything when the asynchronous operation finishes, and so you don't have any problem to solve, right? So the then is sort of mandatory because you want to attach some operations that takes the result of the asynchronous operation. And catch and finally depends on how you want to handle errors that might happen during the asynchronous operations. Okay? The nice thing we should mention is that all these methods, then, catch, finally, return something and actually returns new promise objects. So in short, you can chain promises together. So you have a promise, dot then, and then you can put a second dot then or dot catch and so on. Okay? Because each one of these methods, then, catch, finally, returns a promise, a new promise, okay, that will be settled once the previous one is settled, okay? Good. Why they return something? I mean, the operation is inside the callback, so they don't have to return the result of the operation. The callback decides what to do with the result of the previous promise. Because you remember, it's the parameter that you pass, that you have inside the callback pass to the then and to the catch. Okay? Okay, good. So let's see a more complex example. Okay? And then we will come back to our example with the database. So let's say we have a number of asynchronous operations to do. Like before we read from the keyboard, but here we have a number of asynchronous operations. Each operation depends on the previous one and needs to wait for the result of the previous one. Okay? So, get repository info, it gives us a first promise. Okay? So it's a function that does some asynchronous operation, but to avoid writing a callback inside here and the rest of the code inside this callback, it gives us back a promise. This promise will be settled once the asynchronous operation has been finished. It's like it goes, I don't know, in the database onto a server and asks for information. It needs a way to get this information. And so then P1.then, and then we can pass a callback, immediately pass a callback that will be remembered inside the promise object, the first promise object, and it will be executed when the first promise object is settled. Okay? And as I told you, the then method returns a promise. Okay? So we can call again then on the second promise and do another operation, and so on, and so on. And in the end, we can also attach a callback to a rejected promise. Okay? So you can, let's say, chain a number of asynchronous operations in this way with the then, and at certain point also have the catch to catch rejected promises. Okay? We just need to understand how the values propagate through chain of promises when there are errors. Okay? That's the only missing part. The first operation returns a promise. The promise is fulfilled, so P1 is fulfilled, C1, so this callback, is executed. Remember, asynchronously. Okay? If JavaScript is doing something else, it will wait for this something else to finish, and then it will execute this callback. C1, if C1 returns a promise, if the promise is fulfilled, the value is passed along and is passed to C2. Okay? If this callback just returns a value, simple JavaScript value, not a promise, it will be converted into a fulfilled promise. So basically, inside these callbacks, you can write whatever you want. Okay? If you can even write callbacks that return promises. Okay? That's the simplest case, right? Because in this chain, you just take the promise and pass it along to the next promise in the chain. Okay? If you don't return a promise, any value in JavaScript is converted into a fulfilled promise. Okay? So it means that the value for the promise is the value of the fulfilled promise. Okay, if at a certain point any promise here in this chain is rejected, okay, and there is no catch before, you arrive without executing the then at the first catch. Okay, so the then execute its callback only if the promise that it receives is a settled promise, a fulfilled promise. Okay? If it's a rejected promise, the then does not execute its callback. Okay? And you need to wait for the catch. Okay? So only the catch getting a promise P4 is a rejected promise. It sees that it is a rejected promise, and this callback, since it's a rejected promise, is being attached with the catch method, it will be executed. Okay? So E console error E. Okay? And then finally, typically at the end, because you want to execute it in any case. Okay? So in this example, if any promise from P1 to P4 is rejected, the promise is passed along, okay, and it arrives at the catch callback, which is asynchronously executed, this C4, okay? So just let's try to be as clear as possible. So this attaching the callbacks to the promises happen in the beginning. And depending how the promise, the initial promise is solved, so fulfilled or rejected, determines which callbacks will be executed in the chain, okay? Because since each then returns a new promise and this promise is attached to another promise, if it gets a fulfilled promise, it executes the callback attached before to the then. Otherwise, simply go on and pass the promise along until you find a callback attached with the catch method, okay? I hope it will be more clear when you experiment it yourself, okay? So let's see an easier way to chain promises, okay? Typically, you don't define P1, P2, P3, and so on because it gets confusing. Just you write code like this, get rep info, dot then, dot catch, dot finally, and so on. So it's just a chain of promises, okay? Because each method returns a new promise, okay? So it's like having many tries, and at a certain point you have a catch and you have a finally. In case something fails, you go to the catch, and then you go to the finally. So basically, here we don't have the need to nest operations anymore. Okay? So we solved our initial problem. It was nesting code inside other code. Okay? The only thing you need to remember, well, one of the many things you need to remember, but actually very important one, the only very important one thing you need to remember is that in each callback here, always return the result. Otherwise, the next callback in the callbacks in the chain will not get the results from a previous promise. Because the default behavior of the then, the catch, and so on, is to take the result of the callback and put it as the value of the fulfilled promise. Okay? If you don't return anything, you have nothing, right? You have the undefined, and then the next callbacks expect a value from the fulfilled promise, but you have undefined, and so basically they don't work. Okay? So you recognize here the arrow function, you recognize there's just one statement here, and so this one statement without the curly brackets is also a return value. It's like you open the curly brackets, it's return get issue. Okay? So the value is returned by each one of these arrow functions. Okay? It's very important to remember. One of the one of the things that might happen, one of the mistakes that might often happen, especially in the beginning when you're experimenting with promises. Okay? Okay, another example, and then we'll experiment a little bit. Yes, we'll stop at the async and wait. So, note that you can create promises also with so-called static methods. You know that JavaScript is not really object-oriented as traditional object-oriented programming languages, but you can directly create a fulfilled or rejected promises with static methods of the object promise. So let's say you have a function, some code somewhere. At a certain point you want to return a resolved promise, but you didn't start with a new promise, resolve, reject, and so on. You can simply create a promise that has already been fulfilled or rejected. Okay? Not just start with a pending state. New promise starts in pending state. Instead, here, promise resolve is a promise that is already in the fulfilled state. Okay? So it has already been solved and it has a value. And sometimes it's convenient because maybe you have a function in other parts of the code that expect a promise. But you already know that this promise should be fulfilled. So no errors can happen. Okay? And so you can just write promise resolve and immediately create a new fulfilled promise. As well as you can do the opposite, promise reject and create a rejected promise. Okay? Just because maybe in other parts of the code you expect a promise, but you already know that the promise is fulfilled or rejected. So in this case, maybe you don't have an asynchronous operation. You just simply want to pass along a rejected promise, because then you have a chain where you have then, catch, catch, and you want to go to the first catch. Okay? And so you passed a rejected promise, and you create it in this way. Yes, there's a question?
It's not initialized, right? So
it's not?
Initialized with the default value or something. It's undefined at the beginning.
No, the value is what you pass here, response or new error and so on.
When it gets created automatically.
No, when the promise is created, well, automatically means in the pending state. Yeah, the value is still undefined because we don't know.
We are forcing the value.
We are
forcing the value here.
Yes, we are forcing the value. Yes. Basically, we already know that the value of the fulfilled promise is what we pass to the promise resolve, okay? Or to the promise reject. Here, we don't yet know. We need to wait for somebody to call the resolve or reject method of the executor function, okay? Because we don't yet know. Okay. Thank you for the question. Good. Okay. So I tell you because sometimes you see this code, okay? And so you might wonder why I want to create a promise that is already fulfilled or rejected, simply because the rest of the code expects promises. Okay, very simple. Okay, good. So now that we have the promises, can we rewrite the example of the database in a way that we don't have that messy code that we actually didn't write how to write, because one thing should be nested inside the other and vice versa? Well, that's a possibility, okay? That P promise resolve. So here, just because we reuse the variable P, okay, we start with a resolve promise, so just the method we saw, without any value because we don't care about the values, okay? We just care about waiting for executing the asynchronous operations the next times, so inside the loop. And from 0 to 100, P then return insert 1, okay? P then print count and so on. So basically you chain all the operations. And in this way, you are sure that the next callback is called only when the previous asynchronous operation executed by the previous callback in the chain is finished, okay? Of course, this is not the best code we can write, and indeed in the second hour and a half we will have an even better way of writing this code, okay? But this already solves a big problem for us. So chaining operations is asynchronous operations can be solved by immediately returning promises and then attach new code to be executed when the asynchronous operation finishes, okay? And in particular, the promise is fulfilled, so there are no errors. Because of course, if there are errors, we need to decide how to handle these errors, okay? Okay, note that also the DB clause that we have at the end is something that need to wait, okay, that all the other operations have been finished, okay? So it's to be put into a then, it's the last then in the chain, okay? Good, I think we can test this code. I should have it, hopefully. Where is promises? No, that's the await. Query sync. It's another one. No, I don't have it, sorry. Anyway, you can type it and try it. Anyway, the result, we will see the result that is the same that we get with the await. This time we will have numbers in order because each time we insert a new value, and so the count increases by 1 each time, at each step. Okay? Last argument here with the promises. So, if we want to execute several asynchronous operations in parallel, is there a way that we can use? Because until now, I mean, I don't think we really have some powerful way of doing that. Okay? With promises, it becomes very easy. Okay? Because you have methods on the promise object, and this all, for instance, takes an array of promise objects, and it tells you when all operations have been finished. Okay? Because the issue is not executing asynchronous operations. It is understanding when everything has been finished. Okay? Because either you chain them, and so the previous one has finished, you execute the next, and so on. And of course, you wait for all, but you wait for each one of them at every step. With the promise all, you don't have to wait for each one of them. You just pass all the promises that have been returned by all the asynchronous functions you want to execute in parallel, and the promise all gives you back a promise. Okay? So the return promise returns a promise, and the return promise will be fulfilled with an array of fulfillment values, one for each of the promises that have been passed, and it will be fulfilled only. It's not written here, it should update the slide. It will be fulfilled only when all the promises are in settled value, in settled state. Okay? So all the asynchronous operations have been finished. Okay? And of course, there are rules like if one of the promises, at least one, has been rejected, the promise returned by promise all will be rejected. Okay? So you know that there's been a reject inside one of these promises. Otherwise, you have a promise that has a value, and this value contains an array of values because you passed an array of promises, and you need to get the results of these promises. Okay? The input array can contain non-promises too. Well, this is really not so useful actually, because basically everything that goes into a promise and it's just a value, it immediately converts into a fulfilled promise because it cannot fail, it's just a value. Okay? Promise raise, last method, it returns a promise that is fulfilled or rejected when the first of the promises in the input array is fulfilled or rejected. Okay? What's the usefulness of this method? Well, let's say you want to access some data that is stored in different places, okay, the same data, and once you get the data, the first data you get, that's fine for you. You have the data and you don't care about the rest of the requests, okay? Like, data is stored in 3 different places, I just need to recover the data, and the first data that arrives, it's good for me, and I just use it, okay? And I ask to retrieve the data from different places just because one of them might be faster. Okay? So that's the idea of this promise race. Okay? So, in short, when a promise is, when the first of the promises is fulfilled or rejected, this returns a fulfilled or rejected promise. Okay? So, I must tell you, I didn't see anybody of you using the race for the project, and in general in programs it's not so common, while promise all is more common because sometimes you want to parallelize operations. Okay? Even though for our projects, for the exam and so on, it's not really required, okay? Because we are not looking for optimization at this level. Of course, using promises is for sure required, okay, and async await that we will see after. But I mean, parallelizing requests toward the server, probably. We don't really need them, okay, for the simplest case of our project, okay. But for completeness, now you know that in case you have many promises that represent a synchronous operation that can go in parallel, you have a way to handle the result, waiting for all the promises to be settled. Okay, let's see if we can see some examples. Yeah, print. No, I wait for later. This we already tested it. Async await promise. Maybe. Yeah, we can have a look at how a promise looks like. Okay. Now that was the example for the time travel. Okay. So node promise MJS. Use strict. I forgot to delete it. It's an MJS, so it's a module. Okay, we don't really need the use strict anymore. Okay, if it's there, it's still okay. Okay, so node promise MJS. Okay, I call this wait promise with -1, and this wait promise return a new promise. And you remember this function, the executor function, okay? The executor function takes two parameters, resolve, reject. Basically, we decided that our asynchronous function that we wrote ourselves, so this one, if it gets duration less than 0, it rejects because it's an error. Otherwise, it calls the set timeout, and it will call the resolve after a certain amount of time, okay, milliseconds in this case. So you see what happens here. We call wait promise with a certain parameter. This immediately returns a promise in pending state, okay, because the operation has not been executed yet. We attach two callbacks, one for the fulfilled promise. Actually, we don't really have a value. We don't use a value from the fulfilled promise because this example is very, very simple. Okay? You see here it's empty. We just write console success. And instead, with the catch, we attach a callback to the rejected promise case. And here, we use the value of the rejected promise. And how do we use it? It's just the parameter, the only parameter of the callback that we pass, that we attach to the promise with the catch method. Okay? And you see, here we have error with something. And this time travel, etc., is just a string that has been passed as the value of the rejected promise. Okay? Instead, here, resolve is called by the set timeout without parameters. So we don't have anything to get, okay, here in the den. And it will print console log success. So let's call it with, I don't know, 1,000, okay? 1,000 milliseconds. Save. Let's see the result. You see, it takes 1 second, and then it writes success. Okay? Let's put 2 seconds so you see better. 2 seconds, and it will write success. So what happens? I mean, the code, read the function. This is just a function. There's nothing to execute, right? Okay? And then wait promise is called with 2,000. So the wait promise says return new promise. Good. Return new promise, it means there's a promise. We attach two callbacks immediately. Console log success to the fulfilled promise, error, console log error to the rejected promise. And then we wait that somebody executes the asynchronous function, okay? So this executor function, okay, is attached to the promise at creation phase, okay? But then it's we need to wait for the timeout to expire, okay? And when the timeout expires, resolve is called, so the promise goes into the fulfilled state, and our callback is put onto the micro task queue, and when it's time, it is executed. And basically it does console log success. Okay? That's the logical flow of this code. Okay? It's very, let's say, important to remember how it works. Okay? But for sure, you need to practice a little bit. If you are not familiar with promises, it takes, let's say, some time to get familiar by practicing it a little bit. Okay? What's the time? Yeah, I think, before we stop, since we still have some time, I wanted to tell you something that I forgot to tell you last time, okay? Not really forgot, I mean, we didn't have so much time, but one thing is how to create a database with in the SQLite format, okay? You see here we have a way to see the content, right? We add that plugin that is this SQLite, I think. Yes. That helps us to see the content. But what about if you want to create a new database? Okay? Well, you want to create a new database, you need, maybe there is some extension, plugins, and so on. But what we recommend is to use this DB browser for SQLite. So it's a program, standalone program, that is available in Linux, Windows, Mac, all the systems, okay? And you just create a new database, okay? You just choose a name, test, SQLite, whatever, okay? And then you want to create the tables and so on. You create whatever you want, okay? You can create tables, fields inside the table, so columns, specifying the type, etc., 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 okay? The way in which, instead, I recommend you to use this program, especially for the lab, okay, is, for instance, for tomorrow. Oh, no, this is the text. I wanted to show you. Oh, by the way, there is the solution for past lab, okay? Lab code and solution. So lab 1 has the solution, but we are going to see lab 2, which is not a solution yet. But there is a file, well, a database already ready to be used in SQLite 3 format, okay? So you don't have to spend time with this program. But there is also this file that are SQL commands, okay? Basic commands that create a table, okay? So you want to create a database that contains one table with some columns and so on. Just modify this file that I gave to you and use it in the DB browser, okay? So now I think, yes, we didn't create anything yet. There's a tab, Execute SQL. You just run the SQL. Unfortunately, I cannot make it bigger, but I just copy-pasted the SQL, create table, etc., insert into films, values, etc. You can create a database from scratch. You press the execute button, okay? Execution finished without errors. Good. Okay? I think you have to write changes or whatever. Okay? And then you have your database. Okay? So, for the exam or for the labs, you don't like the database that we gave to you. You want to create your own database with your tables, columns, and so on. Just start from this SQL file. Okay? Modify it as needed. It's just SQL, standard SQL. We don't really require anything really strange or difficult. Okay? Just tables with integers, text. Yeah, the auto increment is convenient because it auto increment the primary key. Okay, when you need this feature. Okay, and then I know at the exam there's people that likes SQL a lot and come with foreign keys, constraints, triggers, and anything you can dream of. Okay. But I mean, we don't really require it. And remember, if you use a feature, you need to be able to explain that feature. Okay? It's not forbidden, and typically people who uses foreign keys, triggers, and so on, they are able to explain it. Maybe database courses explain better than the web application courses. I don't know. Okay? Maybe people like SQL more than JavaScript. It might be. Anyway, the point is you need to handle this SQLite format. There's a program that can help you in handling this format. Browsing data. Okay. No, I cannot make it bigger. Anyway. You can browse the content, but you can do it from Visual Studio Code as well. So that's the easiest part. But you can also modify the database. Okay? And this is just an open source program available for any system. Okay? So, I think that's all for now. If you have questions about the promises, I'm happy to answer you. If you want to ask during the break, because you don't want to ask want everybody listen to you, it's fine. Okay. Otherwise, we have a 10 minutes break, and then in the rest part of this lecture, we will see how to use the promises in even more efficient way with the new async await keywords in JavaScript. Okay. And that's all for today. Then, and we finish for today. Thank you.